In a continuation of what we learned last time with the little foldable, all of our congruence theorems, we can now use those congruence theorems to prove things about triangles. So I always say those letters wrong. CPCTC stands for corresponding parts of congruent triangles are congruent. This is what we learned last time, where all of the spaces in the same locations were congruent to each other if the triangles are congruent. So what we're going to use is all of the ideas we did from last time to build proofs. Now these proofs are honestly some of the more challenging but easier versions of proofs we will do all class. Challenging because we've now learned so many rules, how do you pick one, but easy because I'm going to teach you a trick to make sure that you know how to do this correctly. So let's review. What is CPCTC? We use it when we're asked to prove that a corresponding part, I need to zoom in because my handwriting is too big, corresponding part of the given triangle is congruent. So if we are trying to prove a part, we are going to use CPCTC as the reason, all 5 letters. So if we're talking about a specific part, our last proof word is CPCTC. To do this, though, we must first prove that the triangles are indeed congruent before we use CPCTC as a reason for the parts to be congruent. In a little italicized part here, it says we can use our triangle congruence theorem, which is all on that foldable with the open flaps, along with our cheat sheet with the hidden math that we learned about from last time to prove that 2 triangles are equal or to prove that corresponding parts of 2 triangles are congruent. Y'all were really good at the hidden math, especially on the quizzes Kahoot that we just did earlier, where the reflexive property means they're the same thing, or vertical angles. Those are usually the 2 that we see the most. We also see alternate interior angles, so that's pretty good. Now, our first example here is we're just proving that the triangles themselves are congruent. This is not proving CPCTC, it's just proving that the triangles themselves are congruent. Now, most of this has been filled out for you, so let's walk ourselves through it. We're given that side length BC is congruent to AD. So let's color code this just so we know what we're doing. This is telling me that this side length and this side length are congruent. I was also given that those 2 same side lengths are parallel to each other. That was my symbol for parallel. Now it's marked on here, but we're going to mark it with a bigger color just so we can see that. They are parallel to each other. So we have that they are congruent, single tick mark on there, and we have that they are parallel. If we know they're parallel, our spidey senses should be tingling that we're probably going to use some of our parallel rules. Our alternate interior, our corresponding, our exterior, all of those sort of things. So if we look at the proof, they say the first given thing. Side length BC is congruent to side length DA. That means that we have a side that is congruent. So the little extra line over here that's not on a normal proof is for you to put either side or angle so you know what rule to use. The second step here was given. Again, it's just given that they're parallel. They told us that. So the third conclusion we draw here is that angle BCA is congruent to DAC. So let's mark that on our image. BCA is this guy. DAC is this guy. Those purple angles that I just marked are alternate interior angles. So my third reason was, again, the alternate interior angles theorem. That means I have now marked an angle. The third thing that they are telling us in this image is that side length AC is congruent to side length CA. That's this thing in the middle. Well, by the reflexive property, don't we know that those are congruent to each other? They're like the same line. Well, that means we've marked a side by that reflexive property. we can conclude that the two triangles are congruent to each other using one of the many congruence theorems we learned last class. But look at the theorems you have written on the side. What does it say right here? Side angle side. That's the reason that we're going to use to prove that these two are congruent. Side angle side. So while you're doing a proof, if you continue to write down what you have marked as congruent, sides or angles, it will guarantee tell you what the conclusion is at the very bottom. Now that's proving that the two triangles themselves are congruent. If we take it a step further, and we actually want to prove not that the two triangles are congruent, but that two of the parts are congruent, we basically have to start by proving the triangles are congruent first, and then say the corresponding parts are congruent. So let's walk through this proof together. It's going to look very, very similar to the one we did up above, but I'm going to have you write in the statements for practice. It tells us, first things first, that side length BC is congruent to DA. So again, I have these two side lengths being congruent, so we mark them with a single tick mark. That is given to me. It also means we've marked a side. They also tell me that BC is parallel to AD, so we mark that. It is marked on your page, obviously, because it's given. So that's my reason. But since they're parallel, spidey senses go off about things I know for parallel systems. I know that alternate interior angles are congruent. So I can mark BCA and DAC because of the alternate interior angle theorem, which again means I've marked an angle. What is the name of the property that allows me to say that this side length here is shared between both triangles? Does anyone remember the name of that theorem? What's the name of the theorem that allows me to do it? The reflexive property. If it's the same thing, it's reflexive. Kind of like when you look in a mirror. I know reflexive and reflection are not the same words, but when you look in a mirror, you're looking at yourself. This line is the same thing. It's looking at itself. It's touching itself. So this is the reflexive property. Which also means I got to mark a side. Once I have one of my theorems listed on the side here, side, angle, side, I can prove that the two triangles are congruent. So we would say triangle ABC is congruent to triangle CDA due to side, angle, side. That's where we stopped last time. But in this problem, we're actually wanting to prove that side length AB is congruent to side length CD, which we now can do. We can now conclude that AB is congruent to CD because corresponding parts of congruent triangles are congruent. CPCTC. Those two side lengths, if we were to line these triangles up, are at the same location. So since the triangles are congruent, we can say the parts are congruent. You guys did really well with this last time on the Desmos activity that half of you did not finish. Oop, called out. Those two parts were the same, so they're congruent. Easy peasy. Now again, my goal of this lesson is to have you be more comfortable with the difference congruence theorem so that if you were to see them in a proof, you could make the correct conclusion on what the person used to do that proof. But here's what I want you to always think about. Sides, angles, and sides. You just write down what the proof gave you, whether it proved an angle or a side, and if you go in order, it will probably tell you the answer, which is fabulous. That's what we want. The last thing I want us to do is, just because these are going to be good notes for us, we're going to write that this first example is about triangle congruence. This second example is about parts of a triangle. That's the difference between the two proofs there. One of them is about proving the triangles are congruent. One of them is about proving the parts of the triangle are congruent.